So you may have already watched a video about how to write an equation of a line given a point at another point. This time we're going to be writing an equation for a line through 2 points. But we're still going to use this idea. You can write an equation for a line as long as you know the slope and the y-intercept. And I'm going to use the same technique I use with a point and a slope, but I'm going to have to modify it just a little bit for this. What we're going to do first is take a look at finding the equation of a line that passes through these 2 points. We could obviously graph the points and look and see where they go on the graph, trace a line backwards and find the y-intercept, find the slope, and we could be done. That would work, but it's kind of a hassle if these numbers are really big or if they're decimals or something else. So we're going to use a technique that works quite nicely. First off, I know that if I knew the slope, I would put it right here in this box, and I'd put the y-intercept right there. Well, I don't know the slope. They didn't tell me that. But I could sure calculate it. And you can either watch another video, or perhaps you know already how to find the slope. The slope is always the rise of the line divided by the run of the line. And to get the rise, how much you rise from this point to that point, you can simply subtract the y-coordinates. I oftentimes say in class, to get the rise, subtract the y's. So 17 minus 5. You could also write 5 minus 17. It doesn't matter what order you go in, as long as you go with the same order with the other ones. So since we went 17 minus 5, then we'll go 8 minus 2 for the bottom ones, the run. 17 minus 5, of course, is 12. 8 minus 2 is 6. So we ended up with a slope of 2. Great. Well, now we know what goes right in that box. So we could rewrite this equation as y equals 2x, and I just don't know what goes in this box. Here's the great thing, though. Because we're supposed to get the equation of a line, the equation has to work for every point on that line. So whatever number I put in for x, I have to get its corresponding y-coordinate. Well, up here, I have 2 pairs of an x and its corresponding y, an x and its corresponding y. Which one do you want to use? I don't really care. Whichever one you feel is most convenient, I'll use that one. So what this point says is when I put 2 into my equation, I have to get 5. So when I put 2 in, all I have to do is multiply by 2, add whatever this is supposed to be, and get 5. Well, what does that mean this has to be? 2 times 4, of course, 2 times 2, of course, is 4. 4 plus 1 gives you 5. Now you know what goes in the box. Okay? So the equation must be y equals 2x plus 1. And we're done. Here's another example. Find the equation of a line that passes through the points 3, negative 2, and 6, 2. Well, again, I need to find out what goes in this box first, and then I'll find out what goes in the second box. To get the slope, I'll subtract the y's and the x's. The rise goes on top. Negative 2 minus 2 on the top. 3 minus 6. I'll go in the same order as I did. The top one. Negative 2 minus 2 is negative 4. 3 minus 6 is negative 3. So I get a slope of 4/3. And that is what we put in this box. So now I know y equals 4/3 x plus, I still don't know what goes in here, but I do know if I put a 3 in for x, I have to get negative 2 after I get done calculating. Or if I put a 6 in, I have to get 2. I'll go ahead and use this pair this time. So when I put in a 6, 4/3 times 6 plus whatever goes right here, I have to get 2. All right, well, 4/3 times 3, you can practice doing fractions times whole numbers, and whatever technique you use, you end up with 8. So 8 plus what gives you 2? Well, that's going to have to be negative 6. So I now know what goes in the box here. So here's your equation. Y equals 4/3 x minus 6, or if you want to write plus negative 6, you're good to go as well. All right? So I hope you found that helpful.